Hi everyone, welcome to my channel. This is Leo, and let's do some more Leetcode problems today. Today's problem is called Unique Path 2. We were given an n by n integer array grid, and this setup is pretty much like the first unique path. The difference is we now have obstacles, so no one should pass the obstacles. Okay, and we're going to return the number of unique paths reaching the bottom right corner. So for this problem, I think it should be pretty easy. If we encounter a obstacle, we just set the DP table here to 0 so that we don't have to calculate any path from here, okay? But the neighboring cells won't be affected because there are other pathways, okay? So let's try to code it out. And if we, let's say if we have the obstacle at the beginning point, we should return 0 at this moment. And if it occurs in the first row or the first column, we can do something accordingly to it, okay? So let's say if we have, so 0 stands for a clear cell, and 1 stands for the obstacle. So we can set the DP table to 0 as the number because we are facing an obstacle, okay? So let's code it out. It should be pretty easy. So, okay, we write it this way. First, we set up the original one. If the first element is 1, we'll return 0, okay? And next, in order to optimize on space complexity, we can use the original DP grid. So we can set it to 1, and we can fill the first row and the first column first, okay? So I0 is equal to, if it itself is 0 and the cell above it is 1. In this case, so that's what happens with the first cell. If this is the case, we can name it to 1 because we don't have any real obstacles. But if not, like if we have a second, here we have something like this, and there's 1 here, and this is 0, we can still set it to 1, right? Because we're going up to down. But if here the above is an obstacle, and we will set it to 0, okay? And else for this, obstacle 0j equals to obstacle 0j equals to 0, and obstacle 0j minus 1 equals to 1. If that's the case, we can write it to 1, okay? All right, so now we're set up. Now we can loop through 1, 1 to the end of this grid. If our current cell is a go, we can add it, update the current grid with I minus 1j plus ij minus 1, okay? Else, if it's a obstacle, we'll just reset it to 0. And now we can return the n minus 1, n minus 1. Okay. Should be index out of bound. Okay. Oh, I see the problem here. So I should go with 1. Start from 1. All right, it passes. So what's the complexity of this problem? So we're looping through every element in this grid. So it's going to be mn. And since we're optimizing the space by writing directly to the original grid, the space complexity is 1. Right? Thank you so much for watching. If you like this video, remember to like and subscribe. I'll see you in our next video.